Recording in progress.
This is Imamul Kabir. I'm going to describe some questions based on my previous presentation on the topic of highly integrated microfluidic device, which is used for cell pairing, fusion, and culture. And I also suggested some necessary improvements based on this device. So I'm going to answer the questions. In the first questions, I am asked why NDV force is required for the good contact of the two cells after trapping. I previously described for the cell loading, first the positive dielectrophoresis force is applied with high frequency AC signals. So after trapping in the trenches of the cells, they have a good distance. So for the good fusion condition, they need to contact each other. For this, reducing distance, a negative dielectrophoresis force is applied. We know that in the negative dielectrophoresis, there is a condition that the medium will be more polarizable than the materials, so that the particles are moving against the increasing electric field. That's why from the two trenches, the cells came to each other against the electric field, and they have a good contact. Here we can easily see that in the figure 1.3, they have a good contact between two cells after applying the negative dielectrophoretic force. And the second question is about the basic between the difference of positive dielectrophoresis and the negative dielectrophoresis. We know that in the positive dielectrophoresis, the condition is when the particle is less polarizable than the particle is more polarizable than the medium. When the particle is more polarizable, then it is more polarized than the medium under the non-uniform electric field, so that the particles is moved towards the increasing electric field. We can easily see that in the figure 2a. This is positive dielectrophoresis. Due to the non-uniform electric field is applied here, the particles are more polarizable and it is moving towards the increasing electric field. And due to the case of negative dielectrophoresis, the condition is reverse as compared to the positive dielectrophoresis. In the negative dielectrophoresis, the particles are less polarizable than the medium. That's so as the medium is more polarizable, the particles are less polarized due to the applying non-uniform electric field. Therefore, the particles moves against the increasing electric field. This is the negative dielectrophoresis. In question 3, I am asked, in the new method 3 for bipolar pulses, what is frequency or switching time suitable for this cell fusion? I'm going to describe in this way that for my new improvement methods, I want to use the bipolar pulse approximately the period half of the unipolar pulse. Like we can easily see that in A, for the unipolar pulse, there is 40 microsecond, but in the B, I show that for bipolar pulse, the period is the half of period is 40 microsecond. So I can easily say that in case of unipolar pulse, the period was 40 microsecond, and in case of bipolar pulse, the period is approximately same, but it is divided into two parts, the upper and lower parts. So the two portion actually includes the total period of the bipolar pulse, 20 microsecond and 20 microsecond, and there is a lag of 5 microsecond. With this bipolar pulse duration, we can easily got this kind of similar results. The high fusion rate compared to the unipolar pulse and the lower mortality rate due to using the bipolar pulse compared to the unipolar pulse. In the question 4, there is a confusing questions. So I'm going to answer these questions. So the question maker told that 96% cells are successfully transferred. So all cells become dead. So, and I also described the content related to the fusion rate and the mortality rate. So how can I describe the higher fusion rate and mortality rate? So now I am clear the things that in the left figure, there is a cell culture of different time period. After the fusion, the cells are transferred to the upper portion, cell culture medium of the device. So after the fused, the rest of the cells are transferred to the upper portion for cell culture. So in that time, 96% cells are successfully transferred, which are fused in the lower portion. But they cannot explain about the fusion. Just they explain about their fusion efficiency, and their fusion efficiency is around 20%. And I just relate this with my new method in terms of bipolar pulse. When I use bipolar pulse, the fusion stage, their fusion rate of cells will be much higher comparatively the unipolar pulse, and mortality rate also become decreasing when we use bipolar pulse. So in the fusion stage, there will be much higher rate of cells we got if we apply bipolar pulse instead of unipolar pulse. And with this high amount of cells in the fusion stage, we can easily successfully transfer 96% in the cell culture medium. So when we use unipolar pulse, when we use bipolar pulse instead of unipolar pulse, so 96% cells of high amount of cells are successfully transferred in the cell culture medium. So this is the things we got. If we use bipolar pulse, we got higher amount of cells live cells in the fusion stage, then you can easily transfer 96% cells in the cell culture. Then the question is, when the buffer is changed, will it affect the cells in the microchannels? No, it will not affect. I can easily say that it will not affect in the cells in the microchannels. Actually, there is two buffer. In the first three function, in cell loading, trapping, and pairing, there is DV buffer solution is used until the cells are transferred to the cell culture medium. And just in the cell fusion stage, the solution is switched to fusion buffer solution in case of electrical fusion. In another, PEG solution for the chemical fusion. Actually, this buffer are changed for the fusion stimuli. I mean that the fusion process is stimulated by this kind of buffer switching. So it will not affect the cells in the microchannels. But the recommendation DEV buffer is it should have a low conductivity, which can reduce the DEV-induced Joule heating effect. Otherwise, with higher conductivity, it can affect the cell structure property and also the cell viability. It can change the cell's shape. So it is important to have a low conductivity of DEV buffer solution. And here is the proper condition, proper composition and condition of DEV buffer solution, fusion buffer, and PEG solution. In the question 6, they ask me, after the PDMS is bonded, we can easily see that in figure 1C, the PDMS is bonded here. The middle part of the PDMS is suspended. Middle part is suspended. Is the gap is important? So I have told many times the function of this device is simply trapping, pairing, and fusion before the cell culture. So in the lower portion, trapping, pairing, and fusion occurs, and after flipping the device, the cells are transferred to the upper portion in the PDMS section for cell culturing. Actually, this hollow chamber is used for cell culturing. So I think the gap between the two portions should be important because the gap, the suspended part is important because the cell culture medium can hold the cells with proper condition, and it can also satisfy the cell condition and cell stability. So the gap is important for proper cell culturing. In the question 7, I am asked, what is the main purpose of conducting a cell pairing? Actually, cell pairing is done to make a good contact between two cells before the fusion, which can also enhance the fusion process. And I am asked about the cell-cell attachment efficiency of two different cells, and also asked, isn't there any interference occurs or not? So I'm going to describe the questions in terms of heterotypic fusion. In the field of microfluidics and also the cell biological research, heterotypic fusion is very much important for the genetic evolution, drug research, and also repairing tissues. So I think that there is, if we can have optimal condition for heterotypic cell-cell attachment and fusion, so there will be not any interference between the cells. For example, there is a two cells of myeloma cells and red splenocyte cells. Fusion are described. So in the first figure, in the top left, there is attachment and fusion. We can easily see that compared to the 2, 3, and 4 section, which describes only fusion, attachment, and mixing, we got that after cell surface modification, attachment and fusion means first the cell surface is modified with proper materials like I described in my previous presentation. Here the myeloma cells is modified. Myeloma cells surface is modified with FU3, FUE3 PG lipids polymer, and rat splenocytes cell surface is modified with FUK3 PG lipids. After the modification of cell surface, they are attached and fusion occurs. This is attachment and fusion. So we got the best results at the attachment and fusion. Most of the cells are fused together compared to the 3. And you also see that the cell fusion efficiency compared to fusion and attachment, in attachment and fusion, the cell fusion efficiency is close to 20% for these two cells. And here we can easily see that the fusion, for only fusion, the cell fusion efficiency is close to 0. But when we modify the surface with the PG lipid polymers, the cell fusion efficiency increases to 20%. So this is heterotypic cell fusion, which is widely used today for cellular biology. So I think if we can handle with proper condition, heterotypic cell fusion is possible, and there isn't any interference, I think. In the last questions, I'm asked, NDV force is activated to contact two tough cells. The question is why the paired condition of the cells is good for a fusion condition. I already described in this presentation that after the positive dielectrophoresis force is applied, the cells are attached with the trenches where the electric field is more, but they have a good distance. So for the fusion, they need to close each other. For this, a negative dielectrophoresis force is applied. For the mechanism of negative dielectrophoresis force, the cells become close to each other away from the high strength electric field. So the paired condition after applying the negative dielectrophoretic force is must and good for cell fusion condition. And the second question is how PDEP, NDP can relate with bipolar unipolar pulse. Only unipolar and bipolar pulse, you can do cell pairing, fusion, and transfer instead of PDP, NDP. So the question is conceptual, but I'm going to clear. The thing is that pairing condition is important before fusion. And for this, PDP and NDP force is must. And for PDP and NDP force, we need AC signals. So I think that PDP NDP force is applied in trapping and pairing stage with different frequency AC signals. But I would like to suggest one bipolar pulse system. With this one bipolar pulse system, bipolar pulse system, just varying the frequency high to low, I can shift just two process PDP and NDP for the cell trapping, pairing, and fusion. And after pairing in the fusion stage, I will use the same bipolar pulse system. So I think that one bipolar pulse system can be used for PDP, NDP, and also for the fusion. So when I can use this, the unipolar, we got similar kind of results instead of unipolar pulse, the higher fusion rate and the lower mortality rate for good cell culturing. Here is the references of my presentation. Thank you for watching.